In this video, we are going to discuss refraction through a prism. But before we do that, we will understand what do we mean by a prism. Prism is a refracting material bounded by 5 plane surfaces with a triangular cross section. While drawing a ray diagram for a prism, we only show the principal section of a prism, which is actually a triangular surface. Consider triangle ABC representing the principal section of the prism. A ray PQ is incident on the surface AB of the prism. This ray should have gone straight in the absence of this prism according to rectilinear propagation of light. But in the presence of a prism, this will not be the case. To show how this ray deviates from its original path, we draw a normal N1 on the surface AB. The angle between the normal and the incident ray is denoted by letter I, and it is called as the angle of incidence. Since the ray is traveling from a rarer medium to a denser medium, it will bend towards the normal. The ray QR thus becomes the refracted ray. The angle made by this refracted ray with the normal is denoted by letter R1 and is called as the angle of refraction. We should note that AC is again a glass-air interface, and thus light will not follow its original path. To show the change in path, we should draw a normal N2 on the surface AC. The angle made by the refracted ray QR with the normal N2 is denoted by R2 and is angle of refraction. At the surface AC, the light ray is going from glass to air, that is from a denser medium to a rarer medium. Thus, the light ray now bends away from the normal. Here the ray RS is called as the emergent ray. The angle made by this emergent ray with the normal is denoted by E and is called as the angle of emergence. Now, if we reproduce the emergent ray backwards, it will intersect the incident ray at point T. The angle made by the incident ray and the emergent ray reproduced backwards is denoted by delta and is known as the angle of deviation. This is the angle that we are looking for. In order to find this angle, first we consider triangle TQR. Angle delta is exterior to triangle TQR. Thus, it should be equal to the sum of the two interior angles, angle TQR and angle TRQ. From the figure, it should be clear that angle TQR is equals to I minus R1 and angle TRQ, it should be equals to E minus R2. Putting these values in the above equation, we get delta is equals to I minus R1 plus E minus R2. We can rearrange this equation and we can have delta is equals to I plus E minus R1 plus R2. Now we consider quadrilateral AQOR. By using the angle sum property, we can have angle A plus angle AQO plus angle QOR plus angle ORA, it is equals to 360 degrees. Now since both angle AQO and angle ORA are 90 degrees, therefore the equation reduces to angle A plus angle QOR is equals to 180 degrees. Let this be equation number 2. Now, if we consider triangle QOR, by using the angle sum property, we will have angle RQO plus angle QOR plus angle ORQ. This will be equals to 180 degrees. Since angle RQO and angle ORQ are R1 and R2 respectively, therefore our equation reduces to R1 plus R2 plus angle QOR equals to 180 degrees. Comparing equation 2 and 3, we get R1 plus R2 plus angle QOR equals to angle A plus angle QOR. Cancelling out QOR on both sides, we have R1 plus R2 equals to A. Using equation number 4 in equation number 3, we get delta equals to I plus E minus A. This is the final expression that we get for angle of deviation. Looking at the final expression, we should understand that the angle of deviation depends upon the following 4 factors. Number 1, the angle of incidence I. Number 2, the material of the prism. Number 3, the angle of the prism A. And number 4, the color or wavelength of light used. We will understand each of their dependence in a detailed manner. Let us first begin with angle of incidence. Experimentally, it has been observed that as the angle of incidence increases, angle of deviation first decreases. It reaches a minimum value. This value is denoted by delta minimum. As we further increase the angle of incidence, the angle of deviation starts to increase. This variation is graphically represented by what we know as delta I curve. At the position of minimum deviation, the refracted ray inside the prism is parallel to its base. In other words, it means at delta is equals to delta minimum, angle of incidence becomes equals to angle of emergence. Now if we substitute this in our final expression, which is angle I plus angle E is equals to delta plus A, delta minimum will become equals to 2I minus A. Now for our second factor, that is refractive index. For a given angle of incidence, with increase in refractive index, the angle of deviation also increases. Our third factor, which is angle of prism, that also directly impacts the angle of deviation. That is, with increase in angle of prism, the angle of deviation also increases. Lastly, we have wavelength of light. We know the refractive index of a given medium, it is different for light of different colors. Refractive index of a material, it decreases with increase in wavelength of light. Thus, the refractive index of the material, it is maximum for the light which is of lowest wavelength, that is color violet, and it is minimum for the color red. So this is all for this video. See you in the next one. Thank you for watching.